Have you ever wondered about how bridges survive earthquakes? But a hidden 1970s discovery keeps these giants standing. Earthquakes don't just shake bridges, they violently tear them apart. Instead of resisting the ground, smart bridges actually float. Giant rubber pads absorb the violent shock waves beneath them. It's like putting expensive running shoes on a concrete giant. Massive pistons push oil back and forth to stop swaying. That 1970s secret, wrapping concrete columns in tight steel jackets. Now columns bend without breaking, saving thousands of lives. That detail becomes important later. Huge rubber pads sit directly beneath the heavy concrete deck. When the earth violently shakes, these pads absorb the movement. They act like giant shock absorbers for millions of tons. The ground moves rapidly, but the road stays almost still. Without these flexible pads, the concrete columns would instantly snap. It is basically a multi-million-dollar skateboard for highway traffic. A hidden solid lead cylinder sits inside each rubber pad. This heavy metal core deforms to soak up destructive energy. Amazingly, the lead rebonds and returns to its shape. Next, we will see how giant steel cables sway safely. Huge rubber pads sit right beneath the massive concrete highway. They let the bridge slide instead of snapping during tremors. But these black pads hide a secret, heavy metal core. Alternating steel plates keep the rubber from bulging outward sideways. Without these layers, the concrete deck would simply crush itself. It is like putting giant jelly pads under a skyscraper. The bridge sways safely, while the ground violently shakes underneath. That secret lead core melts, turning destructive motion into heat. Once the shaking stops, the solid lead quickly reseals itself. This simple trick keeps vital transit routes open after disasters. Giant hydraulic pistons act like massive shock absorbers during quakes. They convert violent seismic shaking into harmless thermal energy. But a hidden fluid inside holds the real secret. This silicone oil thickens instantly when a sudden force hits. Under normal traffic, it flows smoothly to allow natural expansion. When the earth violently moves, it stiffens like solid rock. This sudden rigidity keeps the bridge deck from slamming wild. It absorbs 90% of the destructive energy instantly. Next, we reveal the flexible joints that prevent total collapse. This massive surge of kinetic energy needs a safe exit. Giant hydraulic shock absorbers sit quietly beneath the concrete deck. They work just like the suspension on your daily ride. Inside, thick silicone fluid fights against a heavy metal piston. This friction turns violent seismic energy into harmless thermal heat. Without this escape route, rigid concrete would instantly snap apart. These massive dampers absorb up to 40% of movement. They literally cushion the entire bridge during the worst shaking. But some bridges survive by sliding on giant metal plates. Massive lead rubber bearings act like shock absorbers for bridges. They allow the entire bridge deck to shift during tremors. The lead core deforms to dissipate energy from shaking ground. Dampers convert kinetic energy into heat to stop bridge swaying. Surprisingly, bridges are designed to dance when the earth moves. Hit the subscribe button and press the bell icon to get updates. Deep piles anchor the structure firmly into the stable bedrock. But the real magic happens inside the massive concrete columns. Internal steel cages keep the concrete from crumbling under stress. Massive steel joints allow bridge decks to slide during tremors. Huge rubber pads sit underneath to soak up shaking forces. But engineers actually want the bridge to bend, not break. Rigid concrete snaps easily, so we use flexible steel reinforcement. Giant hydraulic pistons act just like shocks on your car. Massive weights swing opposite to the earthquake to stabilize structures. Deep piles lock foundations into the earth to prevent sliding. The secret is turning dangerous kinetic energy into harmless heat. Can these structures handle the ultimate test? Find out next. Extreme low-angle view showing concrete piers shaking during tremors. Steel cables stretch like giant rubber bands to absorb energy. Rubber layers beneath the deck allow the bridge to slide. Giant hydraulic pistons turn violent kinetic energy into harmless heat. Engineers actually want these massive structures to dance during quakes. Expansion joints prevent the road from snapping when earth shifts. Leaving empty space is the smartest way to ensure survival. By yielding to nature, these bridges remain standing after disasters. The facts remain, and the search for truth continues.